Here are solutions to quiz 3 from Math 111. In the first problem, we're given this function here, f of x equals x squared minus 2x plus 1, and asked to evaluate all of these things. So it's kind of understanding this notation. What f of negative 3 means is what would you get if you put in negative 3 into this machine, if you replaced all the x's with negative 3's. So what you'd get is negative 3 squared minus 2 times negative 3 plus 1. Now, which you can then simplify. Negative 3 squared is 9. Negative 2 times negative 3 is positive 6. And 9 plus 1 plus 6 is 16. So f of negative 3 is 16. In other words, if you put negative 3 into this machine, this function, 16 comes out. Okay, what if you put a plus h into this function? Well, what we would do is replace all the x's with a plus h is. So we'd get a plus h squared minus 2 times a plus h plus 1. These parentheses are important. We want to square all of the input. So we want to square this whole a plus h. We want to multiply the input by negative 2. So we want to multiply this entire input by negative 2. And if you simplify this, you could FOIL this guy out and then distribute the negative 2 and get this mess. I don't think there's anything we can do there. I think that's the end. So I guess that's our answer. All right, moving on. F of a plus f of h. So I put this one on to try to confuse, I don't know, maybe there's not the right word, but to point out the similarities between b and c, but you get a different answer. F of a is what we get if we put in a everywhere we see an x. So, I don't know, maybe I can write this over here. F of a is equal to a squared minus 2a plus 1. And f of h is just h squared minus 2h plus 1. So f of a plus f of h is just saying what's this plus this. A squared plus h squared minus 2a minus 2h plus 2, maybe. You don't have to write it in this order. You do whatever you want. Force a habit, I write the terms of largest degree first, which is why these guys came out in front. But I don't care what you do. As long as you get these same terms in some order, you're in good shape. All right, moving on. Number 2 is all about domains of functions. So for domain, we got 2 rules. Can't divide by a negative. That's not true, sorry. Can't divide by 0. And you can't take the square root of a negative number. Really, you can't take any even root of a negative number, but for our purposes, square root will suffice. There's a 3rd rule about logarithms, but we don't need that in this class, so I'll leave it with just these guys. So in this first one, there's no square roots. We don't have to worry about rule 1. That's not true. We don't have to worry about rule 2. But we do have to worry about rule 1. We can't divide by 0, and there are values of x that will make us divide by 0. You kind of guess and check for a while, but a better way to do it would be to set up an equation. Say, all right, I want to figure out what x's make this true. And then what I will do is exclude those from my domain. So one way to do this is factoring by grouping. So we need to find 2 numbers that multiply to a times c, in this case negative 12, and add to positive 11, whatever b is. And those 2 numbers, let's see, how about positive 12 and negative 1? Something like that. So then what we do is we replace 11x with 12x minus 1x, or just minus x. And what that does is it turns this 3-term quadratic equation into a 4-term, which we can then factor by grouping. These first 2 terms have 2x in common, which leaves me with an x plus 6. And to be left with an x plus 6, I'd have to factor out a negative 1 from these next 2 terms. So what that gives me is 2 terms, both with an x plus 6 in them. So I can factor out that x plus 6 and get here. And this is good. Something times something equals 0 is where I want it to be. It tells me either x plus 6 is 0 or 2x minus 1 is 0. So either x is negative 6 or x is 1/2. So think about what we figured out here. We figured out what values will make the denominator 0. Figured out what x's are bad, what x's will make us divide by 0, what x's are not in the domain. What we want to know is what x's are in the domain. Maybe I switch colors because I'm running out of room here. See, we want every number except for negative 6 and positive 1/2. Right, so we want every number except for this guy and this guy. In other words, we want all these guys, we want all these guys, and we want all these guys. So we have 3 intervals. This first interval is everything from negative infinity all the way up to negative 6 with parentheses because we do not want to include negative 6. The middle interval goes from negative 6 to positive 1/2. And the last interval goes from 1/2 to infinity, which I could barely squeeze in there. So down here is our answer, our domain in interval notation. That was a lot of work. This next one I think goes a little bit quicker. Kind of same idea. We want to find the domain. This time we don't have to worry about rule 1 because we won't divide by 0. It's not a rational expression. We don't have any x's in the denominator. But we could take the square root of a negative number. When will we take the square root of a negative number? Well, we're taking the square root of this 3x minus 9. So what we have to do is make sure that this 3x minus 9 thing is not negative. In other words, 3x minus 9 is greater than or equal to 0. So as long as 3x minus 9 is greater than or equal to 0, we won't take the square root of a negative number, we won't get in trouble. So the solution to this inequality will be our domain. And we can solve this by adding 9 to both sides, and then dividing by 3. So what we get is all x's greater than or equal to 3 are in our domain. So we can write that in interval notation like this. If you want a number line, I could do that too. There's 3. We want to include 3, and we want to include everything greater than 3. So because we're including 3, we put brackets here, and then everything greater than 3, everything up to infinity. So there's the domain. Maybe I'll throw some boxes around things to make my answers a little bit more clear. And then we can say this quiz is over.